and then we'll go through your homework. What'd you use? What's it called?
It's just called Socratic.
Socratic.
It just pops up when you type in that thing on like Google.
What do you think? Like, I
Just-
need help with that.
No, I have that one bookmarked. No, you just type in
There's Wolfram Alpha. That's one.
yeah.
Everybody use that one?
I have a bookmark, but not for math homework,
No.
in general.
Just in general, just for little tidbits here and there. All right, I'll go through this with you if you need it. 3699 over there. All right, you will have to prove this, as we have said multiple times. Shouldn't be like a surprise. And so our proof. Start with the cosine of alpha minus beta, and you rewrite it as the cosine of alpha plus negative beta. And now, since we do that, I'm going to put these down below here because they're not actually part of the proof. We can now use the formula cosine of alpha plus beta, which is cosine alpha times cosine beta minus sine alpha times sine beta, which we use in that big long piece, that big long like 11-step proof, just that you don't have to memorize. Some of you were disappointed. But when you do that, you're using, because it's a plus, and I got two angles. The first angle is going to be the same as alpha. The second angle, though, has to be negative beta. So this is the key step here. So it becomes cosine of alpha times cosine of negative beta minus sine alpha times sine negative beta. All right, does anybody know actually what's happening next?
Well, that's because they're odd and even functions, but the negatives on the right cancel. On the right with the sign of
With
the negative on
Yeah.
the sign of beta goes to the outside.
Okay. And what about this one? Cosine negative beta.
It goes away.
It goes away because it's an even function, and cosine of negative beta equals cosine of beta. And so it doesn't go away. You were technically, you're replacing with cosine of beta. And sine of negative beta is equal to the opposite of the sine of beta. So that's where it moves in front, minus sine alpha times negative sine beta. And what you got there is a negative times a negative, which everyone knows becomes a positive. So that's cosine alpha times cosine beta plus sine alpha times sine beta. So that should be our final step there. Further proof, four steps. And then there's your equation. Now remember, you're allowed to write those 6 formulas down for the quiz.
Do we need to have the extra justifications written, or
No.
does it just need to be the 4 steps?
Nope. This is right here, this is all I need to see. Okay, now if you want to do those, can I help you remember? That's fine, but it's not part of the proof. Okay. For that. All right, 23, 25, all right, 25. Tangent of, what is it, 19 pi over 12? And is that 285 degrees? I'm sure most of you converted, which is fine. But what did you use? What two angles did you use to finish it? Did you use 240 and 45? Okay, I got one yes. Did you use something different? What did you use?
I used 5 pi over 4 plus pi over 3.
That's fine.
Which is 225 over and 60.
60, yeah.
Okay, so you can think about it. And I'm gonna do them both. What do we say? It was 285? And so you can either do tangent of 240 plus 45 or the tangent of 225 plus 60. All right. And kind of how you end up, they're going to look different, the answers, and that's okay. That's okay. I'm going to do the one on the left first. And so what is my formula for tangent of alpha plus beta? Help me out here. Is it tangent alpha plus tangent of beta? And is it 1 minus tangent alpha times tangent beta? All right, so 1 minus tangent alpha times tangent of beta. So this is going to become tangent of 240 plus tangent of 45 over 1 minus tangent of 240 times tangent of 45. Well, 240 is in quadrant 3, so it's got to be positive. What is your tangent of 240? I'm just going to put it over here for a second and then erase it. For those viewing at home, 240 would be 60-degree reference angle. Square root of 3 over 2 would be opposite. 1/2 would be adjacent. So the, oh, thanks. There we go. So the tangent of 240 would be square root of 3 over 2 times 2 over 1. So just radical 3, correct? All right, so square root of 3. So that gives me square root of 3 plus, all right, what's tangent of 45? It's 1. 1 minus square root of 3 times 1. So this equals the square root of 3 plus 1 over 1 minus square root of 3. Cooper, does yours look like that?
Yeah.
Yeah? Okay. I thought it might look different. You can leave that, because what did I say? I said don't do what?
Rationalize the denominator.
Go ahead.
Is it okay if I wrote the denominator as negative square root of 3 plus 1? Like I rearranged it.
That's fine.
Okay.
There's absolutely fine. No, all right, so I'm going to leave that. And so that equals square root of 3 plus 1 over 1 minus square root of 3. Okay. I'm not going to get too concerned about rationalizing. I am going to come back to that in 1 second, though. 1 second. All right, so if you use 225 and 60, so tangent of 285 is going to be tangent of 225 plus tangent of 60. Okay, because that's going to be square root of 3 as well, right? And then you get 1 minus tangent of 225 times tangent 60. I thought it might look a little different. But tangent 225, that's 1, right? Positive 1 plus, and that's square root of 3. And then you get 1 minus, square root of 3 times 1. 1 plus square root of 3 over 1 minus square root of 3. Okay. Now, did anybody look at what the actual answer was in the back of the book? And I said you didn't have to match it, but what was it?
Negative 2 minus radical 3.
All right, negative 2 minus square root of 3. Even though you don't have to, how can we take that and get negative 2 minus square root of 3? You do, so in order to do that, you do have to rationalize the denominator. How would you do that for what's shown? Okay.
Would you multiply by the conjugate?
Is would multiply by the conjugate. You cannot just multiply. Let me just make a mistake. Do them all the time. What if you multiply by square root of 3? Why doesn't that work? Because it just gives me square root of 3 minus 3 here, and it gives me 3 plus square root of 3. Basically, it just moves this radical to the other side. Okay, then you can just do that forever. So in order to get rid of it, you've got to multiply by the conjugate. Okay, which is 1 plus radical 3, 1 plus radical 3. You got a FOIL on top, FOIL in the denominator, and what do I get? I get square root of 3 times 1 is radical 3, plus 3, plus 1 plus radical 3. And what am I gonna be left with on the bottom? I get 1 minus 3, it looks like. So I get 4 plus 2 radical 3 over negative 2. And when you divide by negative 2, that's where you get negative 2 minus radical 3. Okay. So you can get what they got in the back, but I'm not overly concerned. You can definitely stop here. One thing you gotta watch, and it might come up in the review sheet here today, is I'm trying to think what it looked like. If you get square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3. Let me just throw that out there. I need to at least have one numerator and one denominator. Like I can't have a complex fraction. So how do I simplify that? What would that look like? So basically take the top and make this 3 over 3. Make this 3 over 3. And that's going to become square root of 3 plus 3 over 3 all over 3 minus square root of 3 over 3. Can I leave that? No. So you got to invert multiply. And so I got square root of 3 plus 3 over 3 times 3 over 3 minus radical 3. Those will cancel. So if you end up with something like this, you at least got to take it to that. And I don't care. I'm not going to make you rationalize the denominator there. Okay? So you should be good there. All right, all I'm going to do is give you this kind of review sheet. And for number 7, it says don't rationalize the denominator. Again, you got a tangent. You don't need to do this. Obviously, if you want to work with somebody, that's absolutely fine. If you get stuck, Lane can give you a hand.
Probably not.
Maybe not. Well, where's the confidence?
John, that's the confidence. He's still.
Okay.
Come on, William.
And you see here that I'll get to see it 2 days, so you know you get an extra day to go over it.
I even gave you Western.
I know. I hope you bring it in.
Yeah.
Are you ready for these?
It might be.
I'd be concerned.
I'm not sure.
The answer key is online as well under today's notes. So if you want to look through that, give you a hand, that's fine.